record button. Thanks so much. And we are the NGSS ESS working group, and we're kicking off this spring webinar series with a new take on the water cycle. And we will, let's move on. And here we go. Just to remind you that this is being recorded, as you just saw, and it will be available in our archives that's on the AGI YouTube playlist. Joining us today are Haley Corson-Dosch from USGS, along with her colleague Charlotte Riggs from the USGS. During today, we'll do some quick introductions. They'll have a presentation for you. Then we'll move into discussion with a Q&A. And then we highly suggest that you take the survey, because we actually like to have your input and your feedback on how our webinar series is going. We take all your comments to heart. With the discussion and the Q&A, feel free to load the chat up with comments and questions, and we'll be gathering them. We'll be answering a few perhaps along the way, but we'll definitely have time for Q&A at the end, and we'll make sure that your questions do get answered. Just to remind you that this is a webinar series, and so we continue into March and April with our webinar series this year. Data puzzles will be the topic of our March series. It's less than a month away. You should be getting, if you have not received an invitation to that webinar, you should be getting it soon. And I hope you join us for that, as well as our April 20th webinar on integrating Earth and Space Sciences into physical and physical science courses. And as a reminder that our entire webinar archive series is available on the YouTube channel playlist, and you can always go back to them. It's nice to have that at your fingertips as a refresher as needed. Okay, and so again, feel free to use the chat box for your questions and your thoughts along the way. And we'll make sure that your questions do get answered. And today's webinar is a new take on the water cycle. And at this point, I'm going to pass it on to our presenters.
Wonderful. Thanks so much, Missy. And I'll get us started as Haley loads up our presentation. So welcome. Thank you, everyone, for joining us today for our webinar presentation about the new and improved water cycle diagram that the US Geological Survey released in October of 2022. My name is Charlotte Riggs, and my pronouns are she and her. And I'm the communications and product management team lead in the USGS Water Resources Mission Area. And Haley, just a quick check that the slides are advancing okay on your end. I'm still seeing the first slide. Sorry for the delay. We'll just, I suspect we're having a technical issue with the PowerPoint.
Haley got booted out again.
And yes, she did. She was afraid that would happen, but she'll be back very, very soon. So thanks for your patience. Okay, Haley, I see that you're back. And are you able to advance the slides, or do you want me to take over trying on my end?
Let me give it one more go.
Okay.
And if that doesn't work, we will. Hopefully Zoom will let me do this. Okay. All right. I'm Haley Corson-Dosch. I'm the diagram's lead designer and a data scientist and hydrologist in the USGS data science branch, and I use she, her pronouns.
Thanks, Haley. As the United States Geological Survey, we collect data and observe phenomena in the natural environment. In the Water Resources Mission Area, where Haley and I sit, we focus on environmental data related to water. We make observations in the natural environment, then we communicate those observations through scientific publications, data visualizations, educational resources, and more. One of our flagship educational resources is the USGS Water Science School, a website for approachable information about water for instructors, K-12 students, parents, and more. And some of you in the audience may be familiar with this website. More than 8 million users visit the website annually, with 1/3 of all traffic on pages and resources related to the water cycle. On the website, we have plain language descriptions of the global water cycle, photos, interactive activities, as well as the new USGS water cycle diagram. Like I want. Today, Haley and I are presenting on behalf of the interdisciplinary team of scientists, designers, and user experience experts who redesigned the USGS water cycle diagram. This update re-envisions the water cycle, placing human activities at the forefront. We designed it to emphasize scientific accuracy, information design, and usability in educational settings. Educators were key contributors to the design of the new diagram. USGS heard from hundreds of educators about how they use the water cycle diagram in their instruction and incorporated their feedback into the design. So during today's webinar, Haley and I will share with you what motivated the design of the new diagram, our user-centered design process. We'll talk about the water cycle science depicted in the diagram, as well as supporting educational resources that are freely available on the USGS Water Science School website. But before we dive into all that, let's find out a little bit about who the audience is today with a quick Slido poll. To join Slido, you can go to slido.com and enter the hashtag water cycle. You can use your smartphone to scan the QR code on the screen, or you can join via the link that Ashley just posted in the chat. So when you get to Slido, please share a little bit about yourself. What is your professional role? And for anyone who is selecting that other category, feel free to put a little more information in the chat if you'd like to about what your role is. Great, so it looks like we have a lot of higher ed educators in the audience, K-12 educators. Others are putting their information in the chat, museum educators, environmental outreach coordinators, PhD candidates, nonprofit project managers. Wow, this is really great to see. And thank you for giving us a little information about who you are. So we're gonna now switch to another poll. Haley, if you could advance to the next one, and this one should automatically update if you're in Slido. And for this one, it's just a couple word response. We invite you to tell us a little bit, if you have used USGS educational resources in the past, which ones have you used? Okay, earthquakes, water cycle diagrams, including our legacy one, photos, water quality information. Oh, NWIS, little call out for our data. Too many to list. Okay, just let folks wrap up what they're typing. This is really great to see just the variety of resources that you're already familiar with. USGS does a lot from earthquakes to ecology to geology and water. So really cool to see that represented here. Okay, well, thank you so much for participating in that poll. Haley, do you want to go ahead and advance to the next slide? Thanks. So it's great to learn about what educational resources from USGS this audience is familiar with, and obviously did note that USGS water cycle diagrams was noted. So let's dive in and start discussing the new USGS water cycle diagram, starting with what motivated the USGS to develop an updated diagram. So when it comes to water, the water cycle is a foundational concept. It's something all people can relate to in some way through our own lived experiences. Additionally, it's taught to students starting at a young age. And in the US, as this audience is very well aware, it's part of the National Science Education Standards, specifically the NGSS Earth and Space Science Disciplinary Core Idea, the role of water in Earth surface processes. And beginning in the K-12 band all the way up through grade 12, students are building an understanding of where water is found on Earth, those water cycle pools, how it moves from the places it's stored, water cycle fluxes, and also how water properties and movements shape Earth's surface and affects its systems. Now, in both formal and informal educational contexts, visuals play a key role in the communication and comprehension of science. Visuals are directly related to how audiences engage with, remember, and identify with a topic or body of work. Compared to text alone, visuals reduce cognitive load, making it easier and more efficient for our brains to process both structured and unstructured information. They can be more engaging and attract broader audiences by being very visually appealing and also relatable. And educators, policymakers, and other professionals all use water cycle diagrams. Water cycle diagrams serve as the single resource that many individuals rely on for their entire knowledge of the hydrologic cycle. Public perception of water movement, quality, quantity, and availability are shaped by diagrams. So it's important that this kind of tool is done right. And there's a multitude of diagrams available of varying complexity and quality. This is a little screenshot of a Google search of images of the water cycle before our new diagram was released. But how well do these diagrams depict our current understanding of the water cycle? For example, since the original USGS water cycle diagram was published in 2000, we better understand the connectivity and interactions between groundwater and surface water. In addition, increasing environmental change and major issues like drought, flooding, and other natural hazards have emphasized the role of humans in the water cycle. Not all diagrams are reflective of our current understanding of water cycle science. In 2019, a team of researchers led by Ben Abbott from Brigham Young University did a study of water cycle diagrams. They analyzed the contents of more than 400 water cycle diagrams from around the world, including the legacy USGS diagram. And Ashley just put a link in the chat to that scientific paper if you'd like to check it out. In their study, they found that 85% of the diagrams they looked at showed no interaction between humans and the water cycle. In addition, 95% of the diagrams they examined focused exclusively on a single catchment or watershed, which ignores important water movement that occurs between watersheds or over long distances. And finally, most of the diagrams they examined omitted or underrepresented major water pools on Earth. For example, 50% of the diagrams underrepresented or omitted 5 of the 10 largest global water pools: non-renewable groundwater, permafrost, saline lakes, wetlands, and soil moisture. Most diagrams also omitted or underrepresented major fluxes of water. Those are the processes that move water from place to place. For example, 92% of diagram omitted the largest global water flux, which is ocean circulation. As a federal science agency, one of the most important things we do is provide high quality scientific information to the public, including by communicating our science through high quality visuals. That's why, motivated by the findings in the Abbott et al. Study I just described, the USGS set out to create a new diagram in order to better represent our current understanding of hydrology and how humans interact with the water cycle. The USGS Water Resources Mission Area convened an interdisciplinary team of scientists, designers, and user experience experts to design a new diagram. The goal was to accurately depict the best water science knowledge available, to use design effectively to make the information digestible and to guide the audience, and to facilitate use in educational settings. We set out with an 8th grade level in mind to meet US science education standards and serve the broader population. So now I'm going to turn the presentation over to Haley, who is the lead designer for the diagram, who will tell you more about the diagram design process.
Great, thank you, Charlotte. All right, so let's dive behind the scenes and talk a bit about how we actually designed this new diagram. So a team of designers, usability experts, and communicators worked together for 18 months using an iterative design process. And all the diagram was created with input from research scientists as well as 100 educators. So the iterative design process that we used is called user-centered design. And user-centered design is a design process where we iteratively adapt our designs based on the context and the needs of our users. As we design, we engage with users, learn about their needs, and we get feedback on the design. We then incorporate that feedback into an updated design and repeat the process. The goal is to put our users at the center of our design activities in order to improve their experience with our products. For this product, educators were the primary user group. Throughout the course of the design process, we talked with over 100 educators from elementary to college level from all across the country. In particular, we wanted to understand how educators teach the water cycle, and we wanted to get their feedback on the design. So early conversations with educators centered on the questions like the following. Which elements of the water cycle do you focus on, and what activities do you incorporate in your teaching? How might a redesigned water cycle diagram support your needs? From these discussions, we learned a lot of useful information, and we use this information to make early design decisions about the new diagram and to learn about future material that could be developed to support the diagram. Once we were actively designing, we had several rounds of interviews with teachers to get feedback on the design so that we could incorporate changes based on their feedback as we worked. Our interviews centered around the following points. Was our depiction understandable? This led to some really valuable feedback. For example, an early version included a drawing of a mine, and it turned out that nobody could interpret it. And since mining is a really important human use of water, we decided to redraw its representation. We also asked, did the placement of pools and fluxes make sense? For example, one change we made based on teacher and subject matter expert feedback was to adjust the location of permafrost on the diagram. We also want to know, are the terms that we're using familiar to educators? It turned out that most educators that we spoke to use the term stream flow rather than the term discharge, which is what hydrologists use. So we made sure that our terminology was not only scientifically accurate, but matched the language that was being used in most grade levels. And then finally, we want to know, did the depiction meet their needs? So by looking at early drafts and potential design variants, educators provided really helpful input into how we used arrows, the style of labeling used on the diagram, and the classes of landscapes that we depicted. So one helpful insight regarding labels was the value in having clearly visually distinct styles to label pools and to label fluxes to help students learn key concepts. So all of this great feedback represented the user side of user-centered design. And now I'm going to speak a bit more to the design side and to some of the information design decisions that we were making and testing while all of this user testing was underway. So if you haven't seen it yet, this is the new water cycle diagram. The full diagram includes that text beneath the illustration, and it's a 38-inch by 26-inch poster. The full-size version is available now on the Water Science School alongside an 8.5 by 11 version and an 8.5 by 11 fill-in-the-blank version. The diagram and the text beneath it were designed for an 8th grade level to meet US science education standards, but we also feel that they can be used for more advanced students as well. All versions are available in English and in Spanish, and we have more language versions in the works. All right, so how did we even start thinking about such a big project? At the outset, we began by reviewing existing diagrams, of course, of the water cycle, but also of other environmental processes, ones that occur across multiple scales, like the carbon cycle, nutrient cycling, pesticide transport, etc. We were looking at a few things in this diagrams, namely the use of perspective, how they use colors, how they chose to place and style labels, how they drew arrows, and how they made use of visual hierarchy. If you're not familiar with the term, visual hierarchy is a design principle by which the most important information is designed to be the most visually prominent. It's important because it shapes how users perceive information and how their attention is focused. So what does good visual hierarchy look like, and how is that even something that designers can manipulate? So to answer that second point first, there are many different building blocks that we can use to tweak visual hierarchy as designers. Some of the simplest are size. So for example, here your eye is drawn naturally to the larger elements. We can also change the color. So here the red element draws your eye more than the blue. Or we can change how intensive a color we're using. Here your eye is drawn to the brighter purple. Or how dark of a color we're using. On a light background like this, your eye is drawn to darker elements. And we're all familiar with this probably without even realizing it. It's used a lot in text media, both online and in print. And it's also used in website development. You can see how in the right image, the most important features like the button draw your eye immediately, whereas the left image seems really visually chaotic. These principles can be used to adjust the design to bring certain elements to the forefront visually and to push others to the back, where your eye won't notice them immediately. It was our awareness of the importance of really good visual hierarchy that actually drew us to landscape architecture diagrams. We were particularly inspired by stormwater diagrams. As you can see in these two here, we really loved that the water was the focal feature. It's highlighted in blue, your eye is drawn to it immediately. And in contrast, background details are shown in grayscale, so your eye goes to them secondarily. Those stormwater diagrams inspired our design aesthetic. So because this diagram is about water, first and foremost, and because water is naturally associated with blue, and because blue is a cooler color that gets pushed to the background when paired with other colors, we made blue the only color used. This helps to make the information digestible and easy to follow, as does some of our other design decisions. So your eye is drawn first to water, just as we want. Shown here, I've highlighted the rivers. Then your eye is drawn to the labels, which are paired with arrows. And we chose to use distributed small arrows to keep your eye moving across the diagram instead of a single big cycle that dominates the diagram. Finally, your eye explores the background landscape and that inset cycle in the bottom right. These elements are drawn in grayscale, which means that they don't draw your eye immediately, but instead serve as details that you can seek out as needed. So between these carefully considered design decisions and the valuable input we received from educators, we were able to craft a visually effective and usable diagram. Now that we've covered the user-centered design approach and some of the key decisions that we made, I'd like to highlight the science depicted in the new diagram. All right, I'm going to start with what we feel to be the most important. So throughout the design process, I'll back up for a second there. Throughout the design process, we consulted with USGS subject matter experts to ensure the scientific accuracy of the diagram. The key scientific concepts that I'm going to highlight here are human interaction with the water cycle, processes that span multiple watersheds, and the representation of key pools and fluxes. The first step to showing human interaction with the water cycle was simply to show humans present on the landscape. The next step was to show key categories of human water use. We have agricultural irrigation with withdrawals of surface and groundwater, water use by grazing livestock, industrial water use, including showing a thermoelectric power plant, because thermoelectric power generation alone is the largest category of water use in the United States, municipal and domestic water use, including a water treatment plant, and then going one step further, we want to not only show types of human water use, but how human water use affects the water cycle. I'll show a few examples of that here. We show how we impact the timing of water movement, for example, by storing and later releasing water from reservoirs. We show how we change the amount of water in different pools, for example, by withdrawing surface water or pumping groundwater, and how that use can cause depletion. We show human activities that can change the quality of water, for example, irrigation, mining, and the treatment plant outflow and industrial returns shown here. We also show more passive, indirect impacts that people might not think of. Wait to that load, such as runoff in urban environments. We show that we affect water timing, so when water moves, quantity, how much water we have, and quality in multiple areas of the diagram. For example, in this closed basin, we show a small city that has a water tower and a factory where water is diverted from a stream to irrigate crops. Here, so much water is withdrawn that the stream dries up, reducing inflow to the adjacent saline lake. The ways in which human actions affect water resources and how climate change is also affecting water resources are key topics that are discussed on the Water Science School. The second key scientific concept that I'm going to highlight is our depiction of multiple watersheds. From the outset, we felt that it was important to visually communicate that the water cycle is not a single big cycle, but is composed of many smaller nested cycles that are active across the landscape. To that end, we included multiple regions: a coastal plain, a dry closed basin, a wetter basin with minimal human presence, an agricultural basin, and each of these have their own unique pools and fluxes. For example, saline lakes, glaciers, reservoirs, but they're connected by processes that occur across watersheds and at continental scales, like atmospheric transport of moisture. To emphasize this, we included an inset overview diagram to highlight those broader connections, including transport of moisture from ocean to land and continental moisture recycling. We also represent key pools and fluxes. We determined which pools and fluxes to include based on peer-reviewed science. We made sure to include key fluxes and pools that are often omitted from other diagrams, as Charlotte mentioned. Some of those fluxes were ocean circulation and precipitation over the ocean, and some of those pools were wetlands, permafrost, soil moisture, and especially groundwater. The pools and fluxes shown here are defined on the Water Science School website. In addition, the magnitude of these pools and fluxes can be explored through an interactive website, which Charlotte will demo later. I want to circle back to groundwater because we intentionally emphasize groundwater as it's a large pool that's hard to understand. Our first goal here was to provide a depiction that improves students' basic understanding. We wanted to get away from the narrative of groundwater as an underground river and instead show that groundwater exists in pore space, in fractures, and that groundwater moves through that pore space. Our second goal was to lay the groundwork for a deeper understanding. We wanted teachers to be able to teach that aquifers are cracked and porous rock or soil that holds water, and to show that those aquifers can be confined aquifers or unconfined aquifers, and that they can have pathways for recharge or not have pathways for recharge. Our third goal was to connect it back to humans. We wanted to show human interaction with groundwater. With these wells, we show withdrawal of groundwater from multiple different aquifers. We show hydraulic fracking, and we show how high pumping rates can cause a cone of depression, and also how high pumping can cause saline ocean water to intrude in freshwater aquifers near the coast. We hope that by providing such a detailed and comprehensive diagram, educators can use the diagram to teach to a wide array of topics related to water resources. And to help them do so, we've developed additional web resources to accompany the new diagram, which I'll pass it to Charlotte to speak to.
Great, thanks, Haley. So I'm going to now give you all a brief tour of some of the supporting educational resources that are freely available on the USGS Water Science School website. So just 1 second while we do our screen share switch. Okay, and Haley, can you just confirm that you can see my screen okay?
I can, yes.
Okay, wonderful. So we'll start here. We'll start our tour at the USGS Water Science School homepage located at www.usgs.gov/WSS. And the Water Science School provides information on several water topics, from water basics to water use, all listed here under this Get Started menu. And on the topic of the water cycle, we have a plain language summary of the water cycle on our main water cycle page here. And this page is available in English as well as in Spanish. The page describes at an 8th grade level what the water cycle is, what pools and fluxes are, an overview of how humans alter the water cycle, and how climate change is actively affecting the water cycle. And at the bottom of the page are links to additional information about components of the water cycle. For example, evaporation, which is a water cycle flux or a process that moves water from place to place. And we're in the process of updating these component pages. So please check back often as we make improvements to them. So at the top of this main water cycle page, you can navigate to several additional resources to support your water cycle instruction, including our collection of USGS water cycle diagrams. Now, on this page, you'll find the newest USGS water cycle diagram, which we released in October of 2022, as well as the legacy diagram and a kids version of the water cycle diagram. If you haven't already, I suggest you explore the zoomable version of the new diagram, which is available in English and Spanish. And I know that Ashley dropped a link to this zoomable diagram in the chat earlier. So this diagram version gives you an opportunity to show this depiction of the water cycle in greater detail from a computer or from a projector. So you can zoom in with your mouse or with the plus and minus buttons here in the interface, and then pan with your cursor. From the zoomable diagram, you can download a poster-sized version of the diagram in either English or Spanish. This whole page can be changed to the Spanish version like that. And again, you can download the Spanish version from the Spanish page or the English language version from this one. Alternately, all of your download options are available to choose from back at that main water cycle diagrams page. So download options at present include a poster, a 26 by 38 inch PDF poster. There's also an 8.5 by 11 inch handout and an 8.5, 11 inch PDF fill in the blank worksheet. And let me just bring that up to show you what that looks like. So this version, I'll make this a little bigger, is a version where the labels for the pools and fluxes have been removed from the diagram up top and are listed down here below. So at present, all the download options are currently available in English and in Spanish, and diagrams translated into additional languages are in the works. We are been working with end user volunteers on these translations. So please get in touch if you are a fluent speaker of a language beyond English and Spanish and would like to volunteer your time to help us produce additional versions of the diagram in other languages. Okay, so just gonna back here for a second. And excuse me, to support your use of the new diagram in your instruction, we also provide a glossary of water cycle terms used in the diagram. So you can find that glossary linked from the main water cycle page. It's available in English, and it is also available in Spanish. In addition, you may be interested in some of the numeric data for the sizes of the major water pools and fluxes on Earth depicted on the diagram. So we've assembled 2 data tables with estimates for all major pools and fluxes from scientific literature available here. The first table shows the volume of water pools, and then the second one shows flux rate of water movement. In addition, we also have an interactive data visualization tools that shows the size of global pools and water and fluxes of water and includes examples of specific pools and fluxes for context. And Haley mentioned this in her presentation, so let's go there now. So again, this is an interactive data visualization, and you can show pools and flux estimates with and without ranges depicted. So here are the estimates with the ranges depicted, or you can show it without. And global pools and fluxes span several orders of magnitude. And so we also give you the opportunity to depict it in log scale or linear scale. And furthermore, we also provide some examples of some specific pools and fluxes for context. So here we have a listing of all the major global pools and fluxes. And then down here, here are some example pools. So you can see, for example, how big the Pacific Ocean is compared to the volume of permafrost across the globe. The last thing I'll mention about this visualization is that the user can select any individual pool, flux, or example that's listed here to bring up a pop-up that provides a definition as well as an estimate. Okay, so I'm going to stop sharing now, and Haley, if you could bring up the rest of our presentation.
Let me just navigate to the end here.
Yeah, no worries. While you do that,
at the beginning. There we go.
It always starts at the beginning. Yeah. So we're about ready to wrap up, and as we do, just wanted to say, like, thank you so much for your attention today and the opportunity to tell you all about the new USGS water cycle diagram. And we're really, really excited to take your questions and comments. I also wanted to mention that please, if you'd like to get in touch with us at any time, you can email the Water Science School team at the email displayed here, water-science-school@usgs.gov. The team will be at the National Science Teacher Association conference in Atlanta in a couple weeks. And so if you happen to also be attending that conference, please come visit us at the USGS booth at the conference. So before we start answering questions, just wanted to open up one last interactive Slido poll. And again, you can join by going to slido.com and putting in the code water cycle, do the QR code, or Ashley has just put the link in the chat. And we'd love to know, what do you like about the new diagram? We'd love to get a little feedback from you. And as folks are putting that in, Missy, are there any questions that you'd like us to direct our attention to first?
That was absolutely terrific. Thank you so much. There was a question from a couple of people that are interested in poster versions of this. Are they going to become available? Can people order them from USGS like we used to get the topo maps and all the other posters?
What a great question. Yeah, got just very, very excited about having physical copies of this beautiful, beautiful diagram out in the world. So the short answer is they're not available at present, but are coming. So they will be available from the USGS store in the future, and we will spread word wide once they are available. You can always be checking on the USGS Water Science School website. We'll make it we'll advertise it once they are available. So at present, the electronic versions are freely available for download, and you can print those, but I understand it's difficult to print a poster size copy, and so please just sit tight and they will be available soon.
So along those lines, there's another question, another technical question, and somebody was asking about a newsletter they can sign up for. Does the Water Science School have a newsletter?
We don't, but what a fantastic idea. So if you're interested in any particular type of information from us, like if you're interested in a newsletter, we would love to know what type of information you would like to get from us via newsletter. So feel free following this webinar. If you have a suggestion, email us at the water-science-school@usgs.gov email and let us know, or you can always put it in the chat here because we don't do that currently, but would love to know how that would be of use to you.
Along those lines, do you have a social media presence, such as in Facebook or Twitter or the like?
Yes, so please follow at USGS _water is the USGS water mission area social media. And then also want to recommend following at USGS _yes, YES. And that's the Youth and Education and Science program at USGS coordinates a variety of programs that target the spectrum of learners from early childhood through postdoc, and they have just really, really wonderful educational resources. So I'll put a link in the chat to their website, and information about their social media is on their website. Oh, I won't put a link right now. I will work on it, and then I will put a link in the chat. And so that definitely recommend to follow their account, the Yes account, as well as at USGS Water. And Haley, maybe you could go back just one slide. I think that the USGS Water social media information might be on a prior slide too.
Okay, we have a few technical questions too. So from Don, he's asking, it's got me wondering about the change in flux related to thermoelectric power production. Greenhouse gas emissions from electric power sector has fallen 40% since 2005. There are a few reasons for that, and I think most of those reasons lead to lower water demand. How easy is it to explore that question using the new model?
As I mentioned, thermoelectric water use was something that we really wanted to highlight because it is such a big use of water in the United States. We aren't able to provide all of the detail and labels that we would love to if we were developing a diagram specifically about that class of water use. But what we hope is that the current representation can facilitate those discussions, particularly alongside resources that are available on the Water Science School website and on the USGS website in general about water use categories in the United States.
Okay. And thank you, Haley. So let's continue. Should the presence of saline aquifers and seawater intrusion be also considered in the diagram?
Yeah, so we do actually show saltwater intrusion on the diagram. That was something that we thought was important to show, given that human pumping in coastal regions can increase that. Let me see if I can back up here so that we can actually be sitting looking at a picture of the diagram as we chat. Yeah, here we go. So we do have saltwater intrusion shown, get the laser, here along the coast.
And did Haley, I don't think your slides advanced for me yet. Missy, have they advanced for you?
Oh, shoot.
No, okay. Haley, we could also move over to the zoomable version if you want to pan around for the discussion.
Oh yeah, that's a good thought. Do you want to?
Yeah, let me do that. I got it up.
Okay. Yeah, at the moment we aren't showing saline groundwater outside of the coastal zones. That's something that we considered, but we were already including a lot of complexity in our groundwater representation. And given that the landscape we were showing groundwater underneath was this alluvial plain, we decided not to show a saline aquifer at this time. But that's exactly the sort of thing that, like, if that would be helpful for you to have a representation of that or to have more content about that on the Water Science School, we would love to hear about that and hear about how it would support your needs. So please send us an email.
Okay. Right, another science technical question, and then we have actually a couple, and then we have a couple more broad questions about the project. So somebody had said, this is excellent. I wonder about the choice of pools and fluxes as terminology. Pool seems very elementary friendly as compared with reservoirs or other terms. However, fluxes seems less kid friendly than flows. I'm curious about what drove this choice, presumably user feedback. Can you elaborate on that?
Yeah, so you're definitely getting at something that we had many conversations about. It was definitely challenging to land on a set of terms, particularly as we were working across English and Spanish simultaneously. In part, it was influenced by the terms that were used in the scientific literature that we were using to drive the design of this diagram. We did also speak to teachers about it. We had some concerns about the term reservoirs because one of the pools that we were depicting is an actual physical reservoir built by humans. And so we wanted to avoid confusion there. Kind of the same thing with flows. You know, we, as humans, we feel like we associate the word flows with just like liquid water or with streams. And so, you know, we wanted to avoid the word flow. We considered using movement, but we felt like that was a little bit unclear. And so what we actually ended up doing was consulting some of the other important cycles that are discussed and looking at the science standards for them, like the carbon cycle, and seeing what terms they were using for very similar concepts, right? It's just the flow of carbon instead of the flow of water. And we found that those were using the terms pools and fluxes. So that kind of solidified our decision, and we decided to move ahead with those terms.
Okay, thank you so much. You know, I thought about that, and it must have been I can imagine the conversation around the table about that and how long it took. So another question, a little bit more technical on the science, and any thoughts about including the hyperrheic zone, which is very important to stream invertebrates and previously underappreciated.
Yeah, so fun to hear that term. I actually did my master's research on the hyperrheic zone carbon dynamics. So yes, that is something we talked about. We did also have a lot of USGS scientists who are really passionate about that. That was, again, one of those challenges of scale. You know, we are just crafting this diagram that is just on a massive scale. So it was hard to, you know, show those really small scale dynamics. That said, we do show, Charlotte, if you zoom in by that left groundwater label, we show rivers contributing stream flow to groundwater. And then in another area of the diagram, further to right on the right panel, we show contribution of groundwater to streams. So while that doesn't really get to the nuance of, you know, that interchange between surface water and groundwater that can happen, we did at least want to show that there are important interactions happening there, particularly because that's one area where USGS science and just hydrologic science in general as a discipline has really advanced their knowledge in the last few decades.
Mm-hmm. Great, thank you. So let's move over to the project, lens. Are you collecting any data on how the new versus the old version is being used and how they promote improved science of water literacy?
Oh, that's a great question. We are tracking analytics on our website, which can only get so far. And so if anyone in this audience of education researchers and educators is interested in exploring and evaluating this question a little further with us in terms of outcomes, let's talk. I'd love to partner with some individuals to dive into that a little more.
Okay, great. And are there any other cycles undergoing updates?
At this moment, there are not. And if I'm would love to hear from the attendees in this audience if there are some particular diagrams that you use a lot in your instruction, and how an update could help. That's something that, we at the USGS Water Resources Mission Area would be interested in that information, but also I know our colleagues in other mission areas like ecosystems would also be very interested to hear that. But at the moment, no other diagram updates in the works.
Yeah, I think you've set the bar pretty high here. Now we have a question about, I guess, the future or the next steps for your diagram. Do you have this in 3D? So this can be placed in an AR augmented reality resource where learners can take them anywhere, any place, and rotate and zoom, helping connect this amazing framework to real items when they are outside visiting places.
What an idea. Wow. That is just mind-blowing to think about. So no, not something in the works. For an idea like that though, something that would be so helpful for us to understand would be how would that really help you advance your instruction? And so I got a little bit of a glimpse in that questions, but the person who contributed, if they could provide some more information, we'd just love to know, like, how do you imagine using that? What would it do for you that a current diagram just wouldn't? What a really, really fascinating idea. Very exciting.
Great. We have a question from Katie about a design choice, and says most common area confusion I see in students is the misunderstanding of water vapor. This diagram doesn't clearly distinguish between clouds and water vapor, especially by not including the condensation step of forming clouds from water vapor. Is this a choice from the grade level standards? And she's mentioning that she teaches at a higher level, so I'm not up on our particulars of 8th grade.
Yeah, so you're getting at another discussion that we had. We did see in other water cycle diagrams that are out there, and I believe including the previous USGS one, that condensation is labeled. Because we were making this distinction between pools as places where water is stored and fluxes as ways that water moves between pools, we chose not to label condensation, because condensation alone, just as your question gets at, doesn't mean that the water is actually changing pools, right? Because the atmosphere can hold liquid water or it can hold water vapor. So you're right, we didn't actually get to the level of labeling those distinctions in the diagram. That's something that can hopefully be covered on the water science school or in class discussions.
Great, and we have one last question, and you briefly mentioned a diagram for younger students. We saw that when you did a screen share. Was that updated as well?
It was not, and I don't have the dates right on the tip of my tongue. I think that the legacy diagram was produced around, I think it was around 2000, and that the kids version of the USGS diagram was produced around 2010. And we have we really focused on updating that legacy diagram from the 2000 era in this project. Something that we would really like to get feedback on from educators would be how you are or could use this diagram and or adaptations of it for younger grades. What would that need to look like? How would something like that meet your needs in ways that this one is not? So again, we'd really, really appreciate some feedback on that as we consider potentially updating that kids version down the line.
Okay, there's a question in the chat box. Let's quickly grab this one, and then we're going to have to move into the close of the webinar. From Jason, he's asking, how about the inset on the Vados zone? Like interflow and involving vegetation, through flow, interception.
Yeah, so you're getting at another really important process that, again, was hard to depict at that scale. That was actually something that we discussed with the USGS scientists being scientists, we always, are really excited about our disciplines, be that beta zone or hyporheic zone or, saline groundwater or snow hydrology or whatever it may be. And there was a lot of interest in having those insets to depict more detailed features of the water cycle, but that unfortunately just wasn't something from a design standpoint that made sense for this product. If we tried to put too much detail or too many insets into this diagram, it was going to become less effective. So what we're hoping is instead that sort of need can be met through the water science school and maybe eventually down the line through some additional sort of spin-off diagrams that share, the same aesthetic, but can dive more into those details and show more zoomed in look for key processes.
Terrific. That's terrific. Okay. There might be a couple questions that'll pop into the chat box as I'm closing, so feel free to take a peek in there and grab them if you can. But I just can't thank you enough for all that you shared today and how excited you got everybody on this webinar about this new tool and everything that goes with it. So Charlotte and Haley, thank you so much for all your time today. So just a reminder to everybody here to watch your inbox for an invitation to our next webinar, which is scheduled for March 9th, 4 p.m. Eastern Time. It's on data puzzles, integrating authentic data and the ambitious science teaching practices to help students make sense of phenomenon. We're super excited to have Melissa and Jonathan joining us for that. And then come back again for April 20th for integrating Earth and space science concepts into high school physics and physical science classes. And reminder that all of our webinars are recorded and they're archived on the AGI YouTube channel playlist. So if there's something you missed, something you'd like to go back to, you'd find everything there. So remind you that please take the post survey. We value your input on how we're doing, and it gives us a little bit of feedback on what to plan next for you. So we are here for you, and your survey comments help us direct our outreach. Hey, we've got something we want to share with you coming really soon. We're developing this new portal for professional development for K-12 educators. And it's a place where you can go to search for opportunities. They may be summer opportunities or opportunities that happen during the year. And we ask our colleagues that offer professional development that are with us today to please jump in and post your materials here. Ed, Aida, and I will be there to monitor progress and this portal and work with you to make sure that your professional development announcements get out there to the greater audience. So Aida, share a little bit about NAGT for us.
Hey everybody, thank you so much for joining our webinar today. Just a reminder that the NAGT, National Association of Geoscience Teachers, does have a webinar series where we really try hard to have one webinar each week. So hopefully we'll see you on our upcoming webinars. You can go ahead and find the schedule by visiting nagt.org/190616. I'll drop that link in the chat box for you. Hope to see you on a future webinar. Thanks, Missy, back to you.
Okay, thanks. It is also brought to you by National Earth Science Teachers Association, the premier earth science organization for our K-12 audience. We have, if you're not a member, we have for you, if you become a member, our quarterly journal called The Earth Scientist. We even ask for you to be an author of articles for The Earth Scientist. We also have our monthly e-news with timely announcements, and we also have a social media presence. So please join us. Ed?
Hi, all. Thank you for being here, and thank you to our presenters for the wonderful webinar this afternoon. I direct education outreach for the American Geosciences Institute, which is a federation of professional societies of all things related to the geosciences. I will just mention that on our website, there's a lot of information for teachers, including our Education GeoSource product, which is a searchable database of resources. As well, we facilitate Earth Science Week in October of every year, and there are a lot of resources for that as well. So please take a moment and look through the website and find those resources. And please be in touch if there's anything we can do to help the work you do. Thank you very much.
Okay, and we wish you all a wonderful day, and thank you so much for joining us. Take care, everybody.